you want to have this type of conversion formulas that tell you what the rates are between your substrate and your product. And luckily for violacine, the genes are known. I found this article made in 2013, and it describes the genes in Bacterium and also other bacteria that have the same genes or produce the same pigment. So Chromobacterium violaceum is also a well-known pigment-producing strain, and they all share 5 genes: VOA, VOB, VOC, VOD, and VOE. They all have that, but that is there are some other genes around that gene. It's mapped pretty well in databases. And they also already found what these 5 genes are doing. So each gene codes for a protein, and each protein is needed in production of violaceum. And the pathway is known. It's actually being derived from tryptophan, and that is an amino acid. So that's a very basic compound in the cell. And you can see here in this flow diagram that's VOD. In the first step on the left adds an oxygen molecule to tryptophan, and then makes some modification in the molecule, and in the next step it's able to merge 2 molecules, and VOC is then adding another oxygen, and then, well, there's nothing besides the arrow over there, but maybe on itself it converts into violacine in the end. So that's already known, so that's great. So this tells me that tryptophan production is really important for the production of violacine. If you have more of the first molecule, then you can expect that you can have more of the product. And I also found more interesting things. The strain produces a metallobeta-lactamase, which is a resistance against antibiotics. Well, that makes kind of sense. It doesn't kill itself when it produces antibiotics. And also found, the chemical formula and the molecular weight, and some information about whether it's soluble in water or alcohols. And it turns out that it's not soluble in water, which is great because then you can extract it with, for example, ethanol, acetone, methanol, and I found in the same article that it has a maximum absorption at 585 nanometers. So with a spectrometer, you can identify